Welcome back. I'm admittedly kinda in a creative crisis. That's why there's only one big blank white space here. And what do you do when you are in a creative crisis? You take something apart. So we're dealing here with a Canon ImageFORMULA ScanFront 300. By the way, that's actually now the fourth scanner I'm taking apart. Before that, I've taken apart 3 flatbed scanners. You see 2 empty shells here. And the third one is nowadays housing my UV exposure unit for PCBs. Cards to everything here and links in the description. This is Robert from the future. This teardown took much longer than I expected. So use the time index in the description wisely. How does that thing work? Obviously, it's not a flatbed scanner. No, it's a sheet-fed scanner. So you have 2 big trays here, an in tray and an out tray. And you can put up to 50 sheets of paper here into the in tray. And then it will scan them, duplex if necessary, and put them into the out tray. And opening these lit trays, you also reveal this large screen here, which is touch sensitive. Problem with that unit, as far as I know, the paper feeding transport mechanism thingy is shot. That's the reason it landed in the trash bin and is now here on my bench. On the back you find 1, 2, 3 USB ports for connecting, of course, a USB stick for storing your scans, but also you can connect here a USB mouse and a USB keyboard if you get tired playing around with a touch screen on the front. You also have here a rather curious 24-volt DC power connector, a Kensington lock and a 100 megabit Ethernet port. On the right side you find a USB port and a rather clunky on-off switch. I mean, really clunky with a mechanical, yeah, that green label here, on-off indicator. Nothing on the left side, and some labels on the bottom. And they say Canon, made in Japan, a product key and serial number. And the thing draws 1.2 amps of that sweet 24-volt DC. Also, it runs on Windows Embedded CE 6.0 and uses a Phoenix BIOS. It uses a run-of-the-mill switch mode power brick that has all the necessary credentials, and it's delivering 2.2 amps. Oh, that's not bad. And it's drawing 1.2 amps at 100 volts and 0.7 amps at 240 volts. Here you also have the pinout of the rather curious connector, and that power brick is made in China, not made in Japan. And here's that power connector. Why don't we switch that thing on for a bit and see what happens? Okay, this is on. There's the blue LED coming on. And oh yeah, it's a Phoenix BIOS boot screen. And it says keyboard error. Okay. So the touch screen is obviously no longer working, and I won't connect a keyboard and so on. That thing is shut, okay? One remark, that thing here was not a power switch, and there is a symbol here. I know it's not a power switch because it doesn't do anything. Obviously that switch, which I will from now on call a lever, has something to do with the paper feed. Just a quick detailed look on the boot screen. So it is a Phoenix BIOS and it's copyrighted 2006. So that unit is really old. Intel Atom CPU with 1.1 gigahertz and 503 megabytes of RAM, odd number. Fixed disk 0, 1 gigabyte NAND drive, so a flash drive with an error. You must reinstall OS image. And then finally a keyboard error, probably because the drivers for the touchscreen as a keyboard are here on the flash drive. But now let's take that thing apart, and I think it will be a while until we reach the screws here on the bottom. There is a lot of snap-in stuff going on before that, I guess. And yeah, let's remove these flaps. This looks flimsy here. So yeah, that comes off easy and reveals the first screw. However, now that flap comes off too. Yeah, maybe we wait with that and continue somewhere else. Let me investigate. Okay, so we will continue with the sides later on. Now that I have a screw here. So I can lift that out here and then lift it out here. And then I have a problem with these flat flex cables, which hopefully are attached somewhere in here. So yeah, let's take these screws out. This seems to be one scan array here. I said that thing is duplex, and these screws do nothing for me. Some snap-in action here, still held down somewhere. Some more snap-in action here, and these snap-ins, they are actually marked here with arrows. Okay, that was number one and number two. And that flat flex is... Oh, nice spring, by the way. We're already in the innards of the whole thing. So this is connected here. Wonderful. First major piece removed. We will come back to that on a later point. Then we have here, sorry, out of focus. Again, caution. This seems to be a high voltage board. Let me zoom down a little bit. This seems to be a high voltage board, and it has a power LED that goes via a light pipe to the front. And it's also connected via that connector here to the big power switch on the front. So yeah, this is interesting. And then it has a little flat flex, 4 lines going here to the back. And it was fed by that flat flex. So let's get that board out, and I need another screwdriver. That's more like it. And yeah, of course my hand is in the way. Sorry about that. A high voltage board. I wonder if they are using 2006 CFLs for lighting, not LEDs. Absolutely possible. Here a little bit of isolation. And here a little switch at the back, which would be actuated by... Oh, I come back to that. I need to get that whole thing here out. Yeah, more screws. So they definitely put some effort into the build. So this is absolutely not flimsy. It's cramped, but it's not flimsy at all. Oh, and I just see, and now I'm zooming down. Yeah, this is, I thought this was some kind of earthing cable, but it's also obviously a little connector. And we're almost there. Okay, now I have to zoom out. Just a sec. So that's the whole scan assembly at the front. And that was the light pipe, and that connector actually goes here inside somewhere. And this was the power button on the front, which you could just push in, and that would actually actuate that little micro switch here on the back of the power board, which looks really interesting. And then we have, of course, our, these 4 connectors here, that little flat flex, that was obviously for the touch screen with some rubber sealings and stuff. Let's put that apart, away. And that's the the LCD itself. So that glass here, this is really just the touch sensor. Probably, resistive. Anyways, you can use that for stuff. Let's get this little module further apart. And I need another screwdriver for that. Something a little bit more appropriate. And now we can take the back off. So that connector here that went to the power board here, that was actually the lighting strip. And that's actually, I can't turn it around now, but I can zoom down. That's indeed a cold cathode fluorescent lamp. An LED panel contains a small amount of mercury. Please follow blah 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 blah. I can't read that. And risk of electric shock. There's that big connector that went back to the main housing. And I don't think we will see too much here. But a little CCFL lamp. Nice. And if we get these screws here off, I'm sure we will see, or just see, the electronics for the LCD display. Yay! So, question is, what kind of data port is that? Let me zoom down. So I turned it upside down. Here are 2 flat flags, big flat flags going into our LCD display itself. And then we have here a whole lot of passives and a few chips. So the really big one, the LCD controller, is a M display Taiwan PFL1-11C. I have no idea about these numbers, probably production date or something. Then we have that really tiny L01 or L01-K2072 and OTD DK073EV8 and an 010K165240006. Next to that big inductor L1, we find that SH5025 101B03 518. I guess that's some power thingy here, switch mode, because the inductor here. And that's it for the board. That was a big conductor in the last chip we had a look at. There's really absolutely nothing, not even passives on the back. So let's try to get out the LCD. To be honest, I don't want to kill it. Because maybe one day, yeah, and there is nothing really interesting beyond that plate here. So let me put that module back together and then we march on. While screwing back the CFL lighting here, I noticed that these are really two completely independent CFLs, okay? And they are connected together here at the end, and yeah, it's hard to make out black on black, but at the very end you can or you cannot make out these two black wires which are joined into that single black wire here, and then the other ends here go into the blue and the pink wire. So they can really independently be switched on or switched off or whatever. I couldn't find a datasheet for that Toshiba LTA084C274F display, but it's 800 by 600 color 6-bit, and that's a low voltage differential signaling interface. So yeah, one channel 6-bit. I don't think I can make that work for me, but anyway. That was the LCD panel here on top, and yeah, there's nothing much left here. Some mechanics, maybe if we can get that spring out, we can remove that here or not. And there's one screw left here. We can just, yeah, preemptively remove that. Oh, yeah, this is some grounding stuff here with little zooming, with little brushes here for the paper to get the static off. Then we can turn the whole thing around and there should be, yeah, a lot of, oh, and these are really, really flimsy and worn. Yeah, the scanner unit here itself, and that should be just a snap-in. Okay, let's have a closer look in a second. Anything more here? More springs. This is all snap-in, I guess. Yeah, it's all pretty worn and dirty. Okay, I try to give you a time lapse of that. Yeah, more brushing here for anti-static purposes. And this copper is really reflecting here nicely, huh? You can never have enough thin copper for yeah, all kinds of stuff. That unit here is also just snapped in. Okay, this will now, oops, fall out on the other side, I guess. Just all the levers and levers for paper transport. Here is a toothed wheel. Nothing of worth. That thing. Okay, but now we're done, but for this black thingy here, which has no purpose at all. That's it. There's some light sensors here, light pipes here. So this is the inside, so to say, and here was the paper running, and here the two light pipes come out. And here in the main body you have basically the transmitter and receiver, or the other way around. But now let's get that scanner thing here apart. That's all snapped in, shouldn't be a problem. This is really just the housing with a little bit of glass and a white stripe. I have no idea what that white stripe is for. And then we have the unit itself, which looks like... let me zoom down. Okay, so I guess this is a single line CMOS or charge coupled device here on the back of that PCB, and this should also just be snapped in. Or is that, no, that's actually heat staked in. Okay, this will get destructive. Give me a sec. Please note that at all times I was cutting away from my fingers. Yeah, and now we should be able to get that thingy here out. Yes, indeed. And yeah, I would have to zoom down for that again. So here under that rubbery goo is the CMOS or charge couple. This is probably a charge coupled device, not a CMOS. And you see there are only passives here because, well, you charge it up and then lights falls on it and it loses its charge, and then you measure that somehow. And the measurement all happens, are we at the end anytime now? Yeah, here. And the measurement, oh, this looks dirty. And the measurements all happen on the main board, which we still have to recover. And yeah, are taken through this connector here. And yeah, there's also here at the end, it looks funny, but that's actually quite powerful RGB LED here, which output is distributed over the width of the scanned page by this light pipe here, which goes smaller and smaller at the end because we have a lot of light here and we need to squeeze out every bit of light we can on the other end. And beside it, that little structure, and you can actually see little light pipes or lenses there. That's the optic for our charge coupled device or CMOS. I think charge coupled, but yeah, don't quote me on that. That was the whole of the front connected through that thing here, the low voltage differential signaling thing for the LCD. And then that was for the power board, and that was the flat flex going to, yeah, the scanner itself in the front. And now we are searching for that Intel Atom processor. Before I crack the case open, please note that that mechanical switch here is actuating that cogwheel here. So in the off position it's down, and in the on position it sticks out and it rotated something. That was that little axis here in the front part for the paper transport. Also, we have here on the front 2 marked snap-ins, and this gives me some hope that we can move something out of here. Nope. Let's try it from the bottom side again. Yeah, that is some snap-in here, and that moves slightly out. That's good. Okay. First look at the innards. Maybe the other side goes that way as well. Yep. More mechanics and a USB port. And there's that actuator from that switch here for the wheel. And now we can get that lid away. And now I think it's time for screwing. We have 2 screws here at the side, but this is just this lever that connected the lid with a bit of spring tension. We already removed that spring. Nothing interesting here. Then we have here a stepper motor and another spring. Springs are always dangerous, so let's remove that. Maybe there's a spring on the other side too. No, doesn't look like that, but now we should be able to get that piece off here, part of the adjustable with paper feet. Yeah, I don't expect anything interesting in here, but anyway. More snap-ins. I'm trying to stay inside the frame. Okay. That's just, some tooth bars and a wheel for the whole mechanics. And that's it. So back to the main body. This will be accessible from the back side, I guess. More snap-ins. I think there's a screw hidden here. No screw. So that was just the back. We're now seeing, there was a provision for a fan here, but there is no fan. Anyway, more screws. I don't know if you can see that. I have no idea if that is the RAM or the flash drive, but you can actually remove it from here. That's actually the RAM, 512 megabytes. I wonder why there were only 503 or so displayed in the BIOS screen. PC2-5300 timing 555. Anyway, we have also 2 micro switches here. One is actually accessible from the back through that unlabeled hole here. And the other one is completely covered up. So I guess one is reset and one is not used, at least in this model. And we have 2 connections here to some stepper motors on the left and the right. And I won't bother with these cable clips here. I just snip them off. I must say, the cabling, it's all very neat. And actually, we have two boards here. So one here on the bottom and another one. That's actually the top, and another one here at the bottom that was holding the RAM, and I see already the atom back there. Anyway, let's disconnect those two. These were, I think, all connections, and there is some more screwing required now. Oh, we have one last snap in. No, first some screws. Okay, there are some more connections. There is one connection here, another connection between the boards, flat flags, and oh, that was that LVDS connection to the LCD. And then we have the processor board. Let's get the board off that plate here. Oh, some glue logic on the back, but yeah, let's have a look at the details. So we have basically two areas here. Here on the right you have all these inductors and capacitors that will generate all the power rails we need. And then this side is probably all the processing stuff. On the back the connectors, and here we have a rather large coin cell for the real-time clock. Right off the bat, within all these inductors and capacitors, and there's also a large diode here at the bottom, we have that LT3728LX. That's probably a switch mode controller or something. A little to the left we have a V5806ONX1. Then there's the chip with the sticker on it, MH4-330201. I would almost say that's flash memory or something. Maybe I can remove the sticker. That's actually R5F21246SN 027 something 3Z001 FP. Looks complex. And just below it we have again a V5806ONX1. I think these are some kind of op amps or maybe full bridge rectifiers. I have no idea. Then we have here with a nice colorful dots an MX25L8005 M2C-15G, and the rest is probably just production date and information. There was our colorful chip, and here we have a Maxim 87966 or 6C or something. Here's that Maxim, and it is a 66 at the end. And then we have here a Delta Echo 3850 N6657. A timer? No, can't be. And right off that we have TPS 51116. Yeah, it's the wrong way around. And a little further up we have a 771AW GGBA 941B. Probably another op amp. And that was just the power supply section here of our main board. On the computing side, we have a WinBond V83627DHC-P. That's either the BIOS or that's the flash drive. Probably the flash drive. I've spoken too early. Right beside it is the SST NAND drive. So that's our flash. That's obviously short 85LD1001K 60-PC-LBTE. Right beside it is another little hidden chip, upside down, LCSG B452. Then, and I'm sorry, it's not my fault. They mounted the chips from the orientation nilly-vanilly. I turned around the board all the time on the power side, but yeah. Anyway, that's an ICS UMS 9001 AKL. I guess that's our USB or Ethernet controller, probably the USB controller. A little glue logic here, S93C45 BDVK. And finally a Texas Instruments 252B04M AP9J. And the big thing is not the Atom, I think. That's a chipset for the Atom. AF82US15W SLGFQ. And that's funny shaped thing here, that's the Intel Atom. Okay. So our main players were the EEPROM, then our flash drive here, the Atom, and probably the chipset for that Atom. And maybe, because it's near the display driver, that's the low voltage differential signaling thingy for the LCD. On the back side, and that was the processing side, on the processing side we have only one chip here, and then there is a lot of op-amp stuff, I guess, all these little thingies going on here on the power supply side. And on the processing side, and I had to turn the board around again, so this direction is the power supply side now, is a Realtek RTL810JEL, probably some I/O chip, USB or Ethernet or something. Just here at the edge of the board we have, I think, I don't look at each tranny, but that seems to be maybe a dual MOSFET JNOA4. And that differential pair here, that's actually the USB port, the single USB port that was on the power supply side away from the processing area. And now the chips are upside down again, so that's some 2210 OF5 62NE, probably just op-amps or something. Another one of those, we already had a look at that pair over here. Two more, and there is actually a sixth one here above the other pair we just had a look at. Okay, moving on towards the edge of the board now. We have here an KAOF1, probably double MOSFET or something, and then another Texas Instruments 252B04M op-amp, I guess. And then we have this whole farm here of four KAOF1s, so double MOSFETs, and it looks like a totem pole driver for something, probably for some of the inductors at the front. And that was the backside of the power section, and everything there is happening here. The second big board here obviously contains the drivers for the two stepper motors, and it interfaced supplied power, I guess, to that high voltage board. I haven't forgotten about that one. Connects to the charge coupled device scanning module. I guess it's charge coupled device. The front, and there should be, yeah, here a second connection to the charge coupled device, which is probably mostly identical to that one in the front, that is that in the back. Anyway, let's get it out and have a closer look. Note, there are again two light pipes here for a paper sensor. And oh, there's a lot of stuff going on here on the back. But I suspect we should find some LEDs and a sensor somewhere here for these light pipes going through here. As mentioned, the front just features these two stepper motor drivers and one additional chip here. And those stepper motor drivers are Shenzhen MTD2039Gs. And that's probably just glue logic S9 3C56 BD VK8 5499. The backside though is quite packed, so we have here a toke MH4-5125 MB87M8280. That's probably a scanner chip here. To its left we have an AKM AK8444V, and that's a Q on O. And to its right, I turned the board, we have an MX T10-211-9 29 LV800 CTTI-70G. That's probably some kind of memory, random access memory. Also to its right, and I turned the board again, is a Winbond WW8912G6IH-75. That's probably some kind of EEPROM. A little bit of glue logic, LCX 00F926. And below it we have an oscillator, 30 megahertz, I guess, AAP-K383G. And here at the top corner we have a little light barrier. And there's the LED for the light pipe, so the transmitter, and here a Q300, so photo transistor, I guess. Here's the receiver. I almost overlooked some smaller stuff here, glue logic, OTS K73, op amp, I guess. That thing is actually so tiny I had to get the macro lens out. It's a PA03 and equally tiny HA5. And all that stuff was located here, here, and here. That light barrier interacts with this black lever here, and that black lever is actuated on the other side here, I think. Yeah, there is a shaft going over here in this direction, and it's actually, yeah, it's really actuated here, but by what? Okay, I got it. So that was the front scanning unit, and there is a little protrusion here that when it's actually closed, it's pressing down on the lever and then activating the light barrier. So it's really just an indication, a sensor, if the whole thing is closed. We have another little board here on the side, but that's really just the fourth USB port, and there's absolutely nothing interesting on it. Finally, the last PCB in detail, that was the high voltage board for the CFLs of the LCD display. And I think, that's the only interesting thing here. That's an MH3-5013B073 from Samida. I guess that's some high voltage generator, and therefore here the high voltage caps and two little trannies, an inductor. The back really just featured that on-off switch here for, the tactile switch for the on-off switch. And that only leaves the two stepper motor assemblies here. I wondered why there are two of them. And obviously, if you actuate these rollers, am I still in focus? Then these are driven by that side. And that big roller here, that's actually the transport for the scanner. And that's basically the feed in from the 50 sheets of paper. And that's actuated one way, so I can move it only in one direction freely, and in the other direction it's actuated here on that side from the other stepper motor. So let's take that apart. Lots of screws. Okay, here's the stepper motor, with a little bit of rubber decoupling, so the thing will not get too noisy. That's a rather big screw for securing a cable. Nothing to see here. Second stepper motor. More belts. Big cogwheel. Smaller cogwheel. Massive copper grounding strip here. And we arrived at the innards. There's the light pipe. There is that lever for the light barrier. That's probably just snapped in. The hard way. I don't mess around with that. Let's try to attack that from the other side. Oh, this is actually pinned in here. That's interesting. Nothing really adds here to anything. So let's get the scanning unit itself out, which is snapped in. Sorry, that was a little bit too close for comfort, I know. Yeah, the usual shielded flat flags, and there it is. It looks a little bit different from the outside, but I guess that's just the form factor, and if we snap that open, it will reveal exactly the same innards. That's exactly the same assembly we've seen before, so no need to get all out on that. That's it for today. It was really astounding how much they packed in such a small form factor, and taking it apart took actually much longer than I expected. Anyway, I hope you enjoyed it. Till next time, bye.